Hello everyone, welcome to another video. This is part 6 of my Gateway API for Kubernetes series, and today I want to follow up on last week's video. In the last week I showed you how we can use the Cert-Manager to automatically create TLS certificates. Therefore we are able to use HTTPS for our applications, and today I want to show you how we can extend this so we can also use Wildcard certificates. The plan for today is I give you a quick introduction into the certificate management, how they are created. Then I'm going to show you how we can validate them, because there are two different ways. The first one is the HTTP 01 challenge. That's the one we have been using so far for specific domains. And then there's also the DNS 01 or 01 for wildcard domains. In the end, I'm going to show you a demo and how we can update our ClusterIssuer so we can also have wildcard domains, and we also have to integrate it with our Azure DNS. All of this will be done with Entra Workload ID, therefore we don't have any passwords and it will be securely integrated. If you don't know Entra Workload ID, I will link you a video down below so you can take a look how it works, where I explain everything step by step. Today I will go over it a bit more quickly because I want to focus on the Cert-Manager. If you're interested in the slides or the demo, you can scan the QR code where you find everything I show you today, and I will also put a link in the description down below. Now let's get started and let's take a look at the entire setup we have right now. So far we have a Kubernetes cluster, we have the Azure Application Gateway for containers, we're using the Gateway API to access our cluster, and in the last video, we have created here the Cert-Manager, and the Cert-Manager is configured to use Let's Encrypt to create TLS certificates. Actually, if I'm a bit more precise, the ClusterIssuer uses the Cert-Manager to get the TLS certificate. So the ClusterIssuer wants a new certificate, and then it tells the Cert-Manager to get it. But the ClusterIssuer has configured where to get it from. For example, in our case, Let's Encrypt. Then the Cert-Manager uses the certificate authority, as I said, Let's Encrypt, and therefore we get our certificates. What's amazing about this setup is everything is automated. So once we set it up, our certificates will be renewed automatically. Also, the certificates are valid for 90 days. This means a very short lifespan, which is good for security, but still they are updated around 30 days before they expired, so we don't have to do anything. Also, the certificates we're using are free and they're fully valid. So our browser will tell us this connection is secure and we don't get any warnings. The way the verification works is Let's Encrypt uses ACME. This stands for Automated Certificate Management Environment. And the reason it has to do it is we have to prove that we own this URL we want the certificate for. For example, I can't create a certificate for google.com because I'm not the owner of it. And if I was able to get a certificate for google.com, I could pretend that I'm them. And this could be very harmful for the security. The way it works is there are two different types of challenges. The first one is the HTTP 01 challenge. This is the simpler one and the one we used for our specific domains or URLs. And the way it works is the Cert-Manager places a file, usually a TXT file, into a well-known folder or path. And then Let's Encrypt checks this well-known path. And if the file is there, then it knows that I own the URL. Because Let's Encrypt connects to the URL I provided and then checks the file path. And if the file is there, it shows I put it there. Then there's also a second challenge, the DNS 01 challenge. And this is used for wildcard certificates. Because for security reasons, we can't use the same approach as before. And so we have to actually connect to the DNS zone and put a TXT file there. Then Let's Encrypt will check our DNS record, and if the TXT file is there, we'll get the certificate. And here you can see everything I just said. I just forgot to go further in my presentation. So as I said, HTTP01, just specific domains. We have this well-known URL, let's encrypt users. And if the file is there, we get the certificate. And also, it doesn't work for wildcard certificates. It's a bit of a pain because it's more complicated to set up, but it's for security reasons. And with the certificates, we want to be secure, so it makes sense. And also, something I already said is with the DNS 01 challenge, we have the TXT record in our DNS. This means we have to configure the authentication from our ClusterIssuer to our DNS. In Azure, we can use Entra Workload Identity. That's the equivalent of managed identities. Therefore, we don't have any username or password we have to manage. So we just use a managed identity. Then we can link a service account in Kubernetes, and therefore our ClusterIssuer can access the DNS zone. Everything is secure, no passwords involved. I will link you a video down below where I explain everything how Entra Workload Identity works, and I will set it up step by step. After we have done this, let's encrypt queries our DNS, and then it will find our TXT record there, and therefore we'll get the certificate. This is the only way how we can create wildcard certificates. Now let's take a look at the steps involved to using wildcard certificates, and then we are going to create them. So first, you have to create the wildcard certificate itself. So this would be, for example, *programmingwithwolfgang.com. Then we are going to attach this certificate to our HTTPS listener. This means in the gateway. And whenever we want to create a specific URL, for example, abc.programmingwithwolfgang.com, we're going to reuse the certificate. Therefore, we don't have to create a new one every time we need a certificate. This can be great, especially in the next video. I'm going to show you how we can deploy our pull request, and we're going to reuse a wildcard certificate to create a unique certificate per pull request. Therefore, we have a unique URL. For example, pull request id.programmingwithwolfgang.com, and it will be fully valid. But for now, let's switch to the terminal and let's get our ClusterIssuer configured so we can create our first wildcard certificate. All right, here in the terminal, we have to define a whole bunch of variables first. So the first batch of variables is for our AKS cluster. This means the name of our gateway, in what namespace we have deployed it, the name of our ClusterIssuer, and also the name of the gateway class we're using. All of this has been set up in the last couple of videos. The next couple of variables are of the already existing applications. So this is the secret name and the URL of Traffic and Nginx. These are the demos I used in the last video to test the TLS certificate creation. Usually in a real-world project, you would have the configuration in a file, for example, in Biceps or Terraform. Then you wouldn't have to recreate it all the time. But since I'm using the terminal, I have to recreate the file. I just can't use it from last time. The next couple of variables are for everything in Azure. So the name of our AKS cluster, the resource group, but also our DNS zone. This means the subscription it is in, because I'm using a different subscription for my DNS zone, the name of the subscription, and also the resource group name where the DNS zone is located. And lastly, we have to configure everything for the Cert-Manager. So today I'm going to create a new namespace. I will call it Wildcard, and we're going to use this one for the testing. Then I'm also going to create a secret name and certificate. This is our wildcard certificate, which I'm going to use in the next video for my pull requests. There you can also see the domain is pullrequest.programmingwithwolfgang.com. Then we provide the managed identity name of the Cert-Manager, or for the Cert-Manager. This is again the Entra Workload ID, because we're going to link the service account name, which we configure here, with a managed identity. Lastly, we configure the namespace of our Cert-Manager. If you watch this video, I know this is a lot of variables at once, but I will have all of this in the description down below, so you can just download the file from GitHub and just copy paste it and follow the demo. Now that we are finally done with all the variables, we can now upgrade our Cert-Manager. So if you followed my videos, you have to do a Helm upgrade. If you're new and haven't followed the videos before, then you can do a Helm install. So first we are going to add the repo of the Cert-Manager. And then in my case, since I already have one, I do a Helm upgrade. So it's up here. Again, if you don't have the Cert-Manager, you can do a Helm install. And what we change here is the last two lines. Here we set the labels to enable the workload identity, and we also set it on the service account. So just a very quick summary how workload identity works. We have a managed identity in Azure. This managed identity has specific permissions. For example, in our case, that it can create a record in our DNS zone. And then we have a link from a service account in Kubernetes to this managed identity. And additionally, we tell the application to use this managed identity by telling it the ID. And then Azure takes care of everything. We can just reference our managed identity and then access Azure services without the need for a password. But as I said, it can be a quite complicated topic. So I have a long video where I explain everything step by step, and we also set it up. So if you are new to this, please take a look so you understand what we're doing here. Changing or updating the Cert-Manager should only take a couple seconds. And once the pods of the Cert-Manager are recreated, we're going to take a look at them. Our Cert-Manager should have been updated now. So let's clean this up. And then we can do a kubectl describe pod. And we select the label where the component is set to controller. We execute this, and now we can see that our pod is running. And if we scroll up a bit, we can also see what we have just configured. So here we have now these fields for the pod namespace, the tenant ID, and also the federated identity token. This is something we are going to create in the next couple steps. But if you see something like this, then you know everything works as expected, or should work as expected. Next, we are going to create our managed identity. This is the managed identity we are then going to link with the Cert-Manager so that our Cert-Manager can actually access our Azure DNS zone. And while I'm doing this, I've also put in the notes a link to the documentation of the Cert-Manager. But if you follow it there, it won't work because there are a couple parameters missing. So if you want to get it set up, please follow this video and not the official documentation, because it will be a bit painful for you. With this said, now we get the ID of the managed identity we have just created. So we just do an easy identity show, and then we query the client ID here. And to check that this works, we can also print it here, and we can see we have our ID. We are needing this ID for the role assignment. So let me paste the next command. Now we do an easy role assignment create. We select the role DNS zone contributor. This will allow our managed identity to contribute to the DNS zone. This means create and delete DNS records. This is necessary because this rule should create the TXT record we need to verify that we own the DNS zone. Then I provide the ID from the managed identity we just queried, and then I query the ID of the DNS zone. All of this is done down here. It's maybe a little bit more complicated than it needs to be, but I chose this approach because this way you can just update the variables and then execute all the commands and don't have to think about anything. So you can just follow it. And I hope this is easy for you to follow. If you have any problems or any suggestions how I can make it easier for you, please let me know in the comments. And with this, our role assignment has been created, no error messages. Now we can set up the last steps we need for the Entra workload ID. So first, we are going to get the OIDC issuer of our AKS cluster. OIDC is the OpenID Connect. That's a standard for a token exchange. And in the second video of this playlist, when I created my AKS cluster, I enabled OIDC. Therefore, I can get the issuer URL. And as you can see, we have it here. And this issuer URL will be used to get the access token. So our managed identity can access our Azure DNS zone. Again, if you've never seen it, it's probably overwhelming, enter a workload ID, but take a look at the video and then hopefully it should be clear. The last step we have to do is the link of our application inside the AKS cluster with the managed identity. So here we create an identity federated credential. Then we just provide a name. Here I like to use Cert-Manager because so I know easily what this identity is doing. Then we provide the name of the managed identity and its resource group. The issuer URL we just queried. And in the subject, we have the actual link of our application to the managed identity. So we say it's a system service account. This is just a definition of Kubernetes. It means we're using a service account. Then we say in what namespace it is and what the name of the service account is. So here we're using the service account of the Cert-Manager. Now I got actually an error message. I think this is because I forgot the parentheses or brackets, whatever it's called. So let's quickly add them. This might be because there's a name in the variable that the Azure CLI doesn't like. Now let's try it again and let's see if it works this time. And it already looks way better. So in this case, it's good to remember if you're using variables, the brackets are always useful. Actually, I just figured out what the problem was. We have here this colon, and obviously PowerShell doesn't know where the variable ends and where the colon is. So therefore we need the brackets. Now if this is out of the way, we can update our cluster issuer. So our cluster issuer can use this identity we have just created to access our DNS zone. So let me paste the configuration. It's a bit long, but then we're going to take a look at everything. So here you can see on the top, nothing has changed from before. We're still using a cluster issuer. I still use here the Let's Encrypt production URL. I also have here the staging one in case you want to use the staging URL. Then we have here the HTTP 01 solver. That's also, again, the same as before, but what is new is here this DNS 01. And here we provide all the information it needs to access our DNS zone. So this is the name, the resource group, and the subscription ID where our DNS zone is located. And lastly, the ID of the managed identity. Once we have configured this, then the cluster issuer can use this managed identity and then access the DNS zone and create the TXT record there. So let's save this in the variable and apply this. Then we're going to wait a couple seconds and then we can display our cluster issuer, and there you should see it updated now. So we do a kubectl get cluster issuer. There you can see it says observed generation 2, because first we have created it in the last video and now we have updated it. The status is true, the type is ready, and we can also see here the ACME account was registered with the ACME server. So all of this indicates everything is working as expected, no error messages, so that's great. Now we can create a test application and test our Wildcard certificate. To test the Wildcard certificate, I'm going to create a new namespace. Then I'm going to deploy a very simple test application in this namespace. So I like to use who am I these days. It's from traffic and also gives some basic information of the pod it's running on. It's a very small image, so it's very easy for testing. What we do here is we have the deployment, just one replica. If we scroll down, we can see here the image. So as simple as it can be. Then we are going to apply this in our new namespace. And also I'm going to create a new service. Again, I keep it as simple as possible. I use the type cluster IP because I want to go through the gateway and I don't want to access the service directly. And then I just use port 80. This means I have HTTPS until my gateway, and from then on I only have the HTTP connection. If you're interested, it would be possible to have a full way TLS. This means also in the backend. But for now, let's keep it simple and just have the TLS until the gateway. So now we have applied also the service. If we wait a couple seconds and then we do a kubectl get all in this namespace, then we should see that the pod is running and the service is also configured. So here you can see the service of cluster IP and the pod on top here also running. So everything looks great so far. Next up, we have to create our certificate. So this is almost the same as in the last steps. So if I paste here the certificate, you can see here the type is certificate. I provide a name. I store it in the same namespace as my gateway is, because then I don't have to create this grant reference to allow the gateway to access it. It would be possible, but again, to keep it as simple as possible, I don't want to mess around with too much configuration. Then we have our reference to the ClusterIssuer. And lastly, we have this DNS name. As you can see here, I'm using the wildcard for my domain. So in this case, it's *.pullRequest, I think it was, .programmingwithwolfgang.com. We're going to store this in the demo, in the variable. Then we're going to apply the certificate. And now all of this, what I said before with the DNS challenge, is happening. This means the ClusterIssuer uses the managed identity we have created to create the txt file in the DNS zone. Then Let's Encrypt will query the DNS, and if it finds the txt file there, it knows that we own this URL and this DNS, and then it will give us our certificate. With the URL specific certificate, it takes around 30 seconds. With the wildcard certificate, it takes around 1.5 minutes. This means 90 seconds. We can also check this by doing a kubectl get certificate with the name we configured and the namespace. And here we'll see that it is false right now, even though it's already 49 seconds old. So we have to wait a little bit longer, and then if everything was set up correctly, it should switch to true. In the meantime, we can also take a look at the challenges. So we can do a kubectl get challenges. That's the way how how Let's Encrypt verifies that we own this through the challenges. If we take a look here, then we can see DNS propagation, pull request.programmingwithwolfgang.com not yet propagated, and it is pending. This means we just have to wait a little bit longer. We don't have an error message. That's already a good sign. So I'm going to stop the video here, wait 1 or 2 minutes, and then we can continue when the certificate has been hopefully created. So I waited, I think, just 1 minute. It's always like a nerve-wracking when you try it out the first time, if it works or not. So let's clean this up and let's check if it is working. So we do again a kubectl get certificate. And we can see our status, the ready one, is set to true. So this means we got our certificate, and this also means we configured everything correctly. So that's amazing. Now we can test it. But before we can test it, we also have to update the gateway, because right now the gateway doesn't know anything about the pull request.programmingwithwolfgang.com. So I'm going to paste the entire gateway and let's take a look at it. So everything is the same as in the last video, except we're going to add the last section. So just to quickly glimpse over it, we have here a reference to the ClusterIssuer. We have here a reference to our gateway class name. Then we have a couple listener. Here we have the listener for port 80, HTTP. Then we have a listener for port 443 for traffic. So we are listening for a very specific URL. The same with Nginx. Again, port 443, HTTPS and Nginx. Both of them have a reference to their certificate. So for Nginx, that is the certificate for nginx.programmingwithwolfgang.com. If you scroll further down, now we have here a new listener. Again, port 443 for HTTPS. We have the host name with the wildcard. So it's the wildcard.programmingwithwolfgang, pull request.programmingwithwolfgang.com. And we also have here the reference to the certificate secret we have just created. This means if a request with abc.pullrequest.programmingwithwolfgang.com comes to the gateway, then the gateway knows that it reached this listener. Then it checks this secret that the TLS connection is valid, and then it will redirect it to our test application. Let's apply this new gateway. Then we're going to wait a couple seconds until all the changes are applied, and then we're going to double check our gateway just to make sure that everything works as we expected. To do this, we do a kubectl get gateway. We provide the name and the namespace of the gateway, and then we can see everything that's going on. So here we have our pull request HTTPS listener. The status is true. We see here the message, the resource has been successfully updated. No error messages, everything is great. Now the last step before we can test this is we have to create an HTTP route. This is necessary because right now we have configured our gateway to receive the request, but the gateway doesn't know where to send the request. So we have to tell it with this HTTP route. That's exactly the same as with the Nginx or traffic. So the type is HTTP route. It is in the namespace we have created for our test application. Then we have a reference to the gateway. So we provide the name and the namespace. And what's important here is this host name. So here I'm not using a wildcard. I'm using a specific URL. In this case, I use PR-2 because in the next video, I want to deploy my pull requests automatically. And I configure the URL to be PR-the ID of the pull request. So therefore, I have a unique URL per pull request. This -2 is just for testing. You can use whatever you want. It does not matter. Lastly, we have this rule. This means we send it to our backend to the service that's called whoami on the port 80. This is exactly the service we have deployed before. Now we're going to save this in the variable and apply the variable. Then again, we're going to wait 3-4 seconds until everything is applied, and then we can check our HTTP route. So you can do a kubectl get HTTP route. We provide the name and the namespace. And here we should also see everything is updated successfully. So here you can see resource has been successfully updated. The status is true. The type is programmed. No error messages. So now we can test our application. This means if you go to the browser, type pr-2.pullrequest.programmingwithwolfgang, we should see our whoami backend. We should have a valid TLS certificate, and we should not have any warnings from the browser that anything is insecure. Now let's switch to the browser and let's see if this is actually true. Here in the browser, we can see we have the traffic.programmingwithwolfgang.com with a valid certificate. This is from the last video. And now we're going to test the pr-2.pullrequest.programmingwithwolfgang.com. If everything works as expected, there it is already. We have our backend. It's maybe not the best example for a demo if I show you traffic first and then this one, because it looks exactly the same. But we can see here our host name. And if you don't believe me that it works, then you can go back in the video where I did the kubectl get all from the namespace, and you will see that the host name is there. Then also we have the certificate. Here you can see the connection is secure. If we click on it, we can see here the certificate is valid. And if we click on this certificate is valid, we can also see here our certificate. It's for wildcard.pullrequest.programmingwithwolfgang.com, and it is valid for 90 days. Also, we can see it's from Let's Encrypt. So everything works as we intended it, and you can also use this for your production workload. This is nothing for testing or anything you should just for trying out. You can actually use this for your productive systems. This was everything I wanted to show you today. For me, this is one of the most exciting pieces of technology, because once it's configured, we can automatically create certificates, we can have HTTPS, we don't have to manage anything, we also don't have to update the certificates in the future. Everything is done by the machine. So we as a human can focus on more interesting work, and also we can't forget about renewing the certificates. It will be done automatically. In the next video, I'm going to combine everything I've shown you so far in this series, and we're going to create a pull request. And during this pull request, we're going to deploy our application into a new namespace. We're automatically going to create a new certificate, a new URL, and this will allow us to access the pull request via HTTPS with this unique URL. This is useful if you have maybe graphical changes or somebody in your organization wants to check it before it's merged to your main branch. And once the pull request is approved, we are going to delete everything, and it is like it never existed. So we don't pay for anything, we don't need any additional resources. And since the certificates are free, we don't have any additional costs. So for me, this is amazing and helps to increase the quality of our software. And it also makes the life of developers and also infrastructure people easier. So I hope you find it as interesting as me. If you have any questions, feel free to leave a comment. If you like this type of videos, please leave a comment. And hopefully I see you next week. We are going to deploy our pull request.